Hello everyone, good morning. Today we are going to study about the blood and its components. Blood and its components. In the last class we have studied about the introduction of blood. Introduction of blood we have discussed. Today blood components we have to discuss. So the blood consisting of two components. Blood consisting of two components. Plasma and corpuscles. Plasma and corpuscles. Okay. These corpuscles also called formed elements. Corpuscles also called formed elements. Formed elements. Plasma. This plasma will be constituting 55% of the blood. Plasma 55%. 55% and the corpuscles 45% of the blood. Okay, the corpuscles will be 45%. 45%. So plasma 55% and the corpuscles 45%. Okay. So coming to plasma, we are going to study the components of the plasma now. So the plasma consisting of 95% of the water, 90 percentage, 90 to 92% between water. (90 to 92% of the water itself, and this water is a good solvent. It's a good solvent, water. Water is a good solvent. So what is meant by solvent? Solvent plus solutes equal to solution. We know that, right? It's a good solvent. The water is a good solvent. And coming to the proteins, 6 to 8%. Proteins will be 6 to 8%. Proteins, 6 to 8% of proteins, and these proteins will be including. These proteins will be including fibrinogens, and globulin, and albumin. Fibrinogen, globulin, albumin. Fibrinogen, globulin, albumin. These are the proteins which are present in the blood. Proteins present in the blood. Okay. These three proteins have their own importance in the plasma. The fibrinogen, it helps in blood coagulation. That means clotting process. The fibrinogen helps in blood coagulation. Blood coagulation. Something like clotting only. Next, the globulin. It acts as antibodies. It acts as antibodies against antigens. Acts as antibodies. Okay, immunity. In terms of immunity, to provide defense to the body. To provide defense to the body, it acts as antibodies. Who globulin. The globulins will act as an antibodies for the defense of the body. Next, albumins. To maintain osmotic pressure and blood pressure. Osmotic pressure and blood pressure. Osmotic pressure and blood pressure. Blood pressure. So every protein has its own importance in terms of different functions by performing different functions. And apart from this water and proteins, the other components includes different nutrients like sugar, glucose, and amino acids, and lipids, and some amount of cholesterol, some amount of cholesterol. And apart from this water, proteins, and different nutrients, inorganic substances also there in the plasma. Inorganic substances also there in the plasma. Here I will write inorganic constituents. Inorganic constituents. So these inorganic constituents will be including sodium, calcium, magnesium, chlorides. Sodium, calcium, magnesium, chlorides, and bicarbonates. So magnesium is dication, so 2+ oxidation state, and even calcium also 2+ oxidation state, and sodium is Na+ only, and Cl- and HCO3- bicarbonate. Oxidation states. Their oxidation states also we should remember correctly. We should mention their oxidation state also correctly. If you choose wrong one, it will become wrong. Okay, especially in MCQs. Mg2+ only we have to select. Magnesium existing in its dicationic form itself. Coming to gases, some gases are present in the blood. Gases in the blood plasma. Gases. So what are those gases? Carbon dioxide, oxygen, and minute amounts of nitrogen. Carbon dioxide, oxygen, and nitrogen. Okay, N2 right here. N2. Nitrogen gas means N2 only. So gases like CO2, O2, and N2 definitely present, right? Have you heard about serum? What is mean by serum? Very simple. Plasma and serum almost are same, but the plasma minus clotting factors equal to serum. Okay. Just I will write the equation here. Serum equal to plasma minus clotting factors. Plasma minus some clotting factors. Plasma minus some clotting factors equal to serum. Okay, just note down the equation and say all the points in the same way you write down, because you can remember easily. Because in textbook they given it like a story, but we written a proper sequence. Okay, different nutrients, first water, then proteins, and then different nutrients, and then inorganic constituents, then gases, and at last what is meant by serum? The plasma minus some clotting factors equal to serum. So we written this. So this is all about the plasma, dear. Okay, now we are going to study about the formed elements, types of formed elements and their points, their importance. We already discussed actually in beginning classes. Before I start the syllabus, I discussed, but now again I am discussing because few students were absent at that time. But this is consider this is as a first time, because that was like a bridge class. So this is the first time I'm going to discuss. Okay. I think I can erase this. Now give your thumbs up reaction so that I can erase. Next, coming to corpuscles, formed elements. The formed elements are three types: RBC, WBC, platelets. Three types of corpuscles. RBC, WBC, and platelets. RBC, WBC, platelets. These are the three types of formed elements. Three types of formed elements. Now, RBC we will study. So, what is the other name of RBC? Erythrocytes. The other name of RBC is erythrocytes. Erythrocytes. The other name of RBC, erythrocytes. Okay. And this RBC are biconcave in shape. Suppose you take this. This is biconcave. This is biconcave. Okay. This is biconvex. This is biconcave. This is biconcave. On two sides, from the two sides, there is a depression. Okay, and circular. Moreover, circular and biconcave. On both the sides, biconcave. Got it? Circular and biconcave. This pattern, biconcave. So circular and biconcave, and there is no any nucleus. Okay, there is no any nucleus in this RBCs. No nucleus. That means enucleated. Enucleated. Okay, and there is no mitochondria, no Golgi complex, since they are having very less lifespan. They are not our permanent body cells. They will be having the limited lifespan. Okay, so that's why they won't have any mitochondria or Golgi complex. They need not to have mitochondria, because what is their function? Not energy generation. The RBC's function is to carry the oxygen and carbon dioxide. That's it. So their major function is carrying as a transporter. They helps, but that their main function is not energy generation. Their function is not energy generation. So no mitochondria, no Golgi complex. No mitochondria, no mitochondria and Golgi complex. No Golgi complex. Okay. Next. And they consisting of a specialized red color pigment that is called hemoglobin. That is nothing but hemoglobin. Hemoglobin. A red color pigment that is nothing but hemoglobin, and it is the iron containing protein. Okay. Iron containing protein. Iron containing protein. And what is heme, what is globin, and how hemoglobin forms, and also how globin forms, what are the polypeptide chains present in the globin. I already discussed in the transportation of gases in breathing chapter. In transportation of gases, I have already discussed with you. So hemoglobin, because of this hemoglobin, because of this ferrous oxidation state 2+, and the red color, the blood gets red color. Okay, and normal hemoglobin range is 12 to 16 grams. Normal hemoglobin level. Normal hemoglobin level 12 to 16 grams per 12 to 16 grams per 100 ml. Per 100 ml. 100 ml. Per 100 ml. 12 to 16 grams per 100 ml. So this is about the introduction. And now some other points we'll discuss, like how many are there, where they're found, and what is the lifespan, and what is their function. These things we'll study now. Okay, here I am writing RBC points. Here I am writing, not WBC. Okay, counter. RBC counter. Almost all 5 to 4.5 to 5.5 million. 4.5 to 5.5 millions per cubic millimeter. Cubic millimeter of a blood. Cubic millimeter of a blood. This is the count of RBC. RBC count. Okay, red blood cells are 4.5 to 5.5 millions per cubic millimeter in blood, and they formed in. So where they are produced? They are produced in red bone marrow. They are produced in red bone marrow. Red bone marrow. They are produced in red bone marrow. So where is red bone marrow is present? In the ends of a long bones. The red bone marrow is present in the ends of a long bones. Okay, red bone marrow. I'll write here. Ends of long bones in the body, like legs, hips, limbs, and like hands. You can get. Okay. You can understand where red bone marrow is present, ends of a long bones. And coming to average lifespan. Average lifespan of RBC is 3 months, almost 120 days. 4 months, 3 to 4 months. But maximum will take 120 days. 120 days is the lifespan. And worn out RBs are destroyed in the spleen. That means the dead RBs will be destroyed in the spleen, dead RBCs. That means after lifespan they will be worn out. So worn out RBCs destroy in the spleen. Destroyed in the spleen. Worn out RBCs are destroyed in the spleen. So the spleen is called the graveyard of RBC. The spleen is called graveyard of RBC. Graveyard of RBC. Graveyard of the RBC. And what is the function of RBCs? Function of RBC. Carry oxygen and carbon dioxide. Carry oxygen and carbon dioxide. Right? So these are all the points about RBCs. RBC points. They are called erythrocytes, and they are circular and biconcave, and they are enucleated. That means no nucleus. Enucleated means no nucleus. Enucleated, no nucleus, and there is no mitochondria and Golgi complex. There is no mitochondria and Golgi complex, and they possess a pigment called hemoglobin pigment. Heme is iron and globin is a protein, and this globin is again made up of polypeptide chains. There are 2 types of polypeptide chains, alpha and beta. 2 alpha chains, 2 beta chains, each alpha containing 146 amino acids, and each beta chain consisting of 141 amino acids, and altogether 1 globin protein consisting of 574 amino acids that we have already studied. Right? Next, normal hemoglobin level is 12 to 16 grams per 100 ml. Next, the function of RBC is to carry oxygen and carbon dioxide, and the count of RBC is 4.5 to 5.5 millions per cubic millimeter, and they are formed in red bone marrow, ends of long bones, and average lifespan is 120 days, and worn out RBC is destroyed in spleen, and the spleen is nothing but graveyard of RBC. Graveyard of RBC. So this is all about the RBC features and important characteristics. Now coming to WBC, we are going to study. I think WBC, vast notes I have given. Whatever comes under Neet syllabus, now I am going to discuss. Whatever in the Neet syllabus, we are discussing perfectly. Okay. In a few things, I am adding extra information also. WBC. White blood cells, WBC, white blood cells. They are also called leukocytes. They are also called leukocytes. They are also called leukocytes. And they are generally colorless and nucleated. Having nucleus. They have a nucleus. Whereas RBC doesn't have a nucleus and they possess nucleus. So that's why nucleated cells. They are enucleated cells because no nucleus. And there are different types. Okay. We will study about the type. First, we will study features of WBC. First, we will study count. Okay, 6,000 to count 6,000 to 8,000. 6,000 to 8,000 per. That's it. Thousands only. Within thousands only. Not millions or trillions or billions, whatever it may be. Only 6,000, 8,000. That's 6,000 to 8,000 per cubic millimeter of a blood. Next, they formed in. They formed in bone marrow itself. They formed in bone marrow, red bone marrow, and also not only bone marrow, lymph glands, okay, and also one more gland in which the white blood cells are produced, that is spleen gland. So in these three locations, the WBC different types are produced, and the average lifespan of WBC is very short-lived, up to 2 weeks. That's it. Up to 2 weeks. Hardly they will live up to 15 days or 2 weeks. 14 to 15 days, 2 weeks only. No. Next, their function. Their function is a part of they are part of immune system. Part of immune system. Part of immune system. Part of immune system. So these all are the points, most important features of WBC, overall features of WBC. Overall features of the WBC. Now we are going to study the classification of this WBC. Classification of the WBC we are going to study now. So can I erase? I think I can erase. Give you a thumbs up reaction if you have done with it. Lakshmi Srija.
Sir, 1 minute, sir. I need to copy.
Please. From this blood topic, we expect one MCQ. From this blood topic, one MCQ in the Neet. We are expecting from this RBC, WBC platelets. All points we have to study. Definitely, we will get one MCQ.
Completed, sir.
Done? Completed?
Yes, sir.
Okay, very good. Today, 26 members attended. It's a good thing. Any new students, please raise your hand. Those who are attended only today. This is the first class. For anybody, please raise your hand. This is the first class. Is there anyone else? Hari, yes. Okay. Hari, consider this is the first class of this chapter. Okay. So be happy. The last 2 chapters you have missed, but the videos are available. I have uploaded on YouTube. Some topics I explained and uploaded. Okay, from this chapter, be regular. It is the first topic of the chapter, circulatory system, first topic today. Okay. Okay. So we are going to discuss the types of WBC now. Types of WBC. Types of WBC. There are two types of WBC. There are two types. Maximum, with the help of flowcharts, we are discussing, so to remember the sequence, the classifications. If we do anything, the classifications definitely will remember. WBC first type, granulocytes. Granulocytes, and second type, agranulocytes. Second type, agranulocytes. Granulocytes, agranulocytes. Two types of WBC. Two types of WBC. Granulocytes. Granulo. They possess some granules. They possess some granules in their cytoplasm. They possess some granules. That's why they are called granulocytes. And agranulocytes, there is no any specialized granules present in that cytoplasm. So they are called agranulocytes. So granulocytes, agranulocytes. Possess granules, do not possess granules. Possess granules and do not possess granules. Do not possess granules. Do not possess granules. Granulocytes, agranulocytes. Possess granules, do not possess granules. Got it. And these granules, which are present in the granulocytes, according to their property, according to their visibility, with the help of a different indicator solutions, chemicals, indicators we use in chemistry, practicals, lab practicals. So those indicator solutions, suppose if we apply acidic indicator, if the granules are visible, they are acidophils. That means the granules respond to acidic stain, and basophils, the granules respond to basic stain, like that. So these granulocytes further classified into three types: acidophils, basophils, neutrophils. Three types. So first type is eosinophils or acidophils. Same. Eosinophils. Okay. Basophils. Second one. Basophils and neutrophils. Neutrophils. Eosinophils, basophils, neutrophils. Eosinophils, basophils, neutrophils. Eosinophils, they are only 2 to 3%. Actually, I have given one tabular form. The tabular form, at the end of this comparison, once I'll give the tabular form, which consisting of all this. But we are studying this according to Neet syllabus. What I have given about WBC, one tabular form, that is little bit extra information. Okay. This is exactly whatever they included in the Neet exam syllabus we are studying. And after this class, if you want, again the tabular form I'll write on the board. Okay. So first, according to Neet syllabus, we'll discuss these points. Yeah. Eosinophils. Eosinophils, otherwise called cyanophils. Cyanophils. Eosinophils are also called cyanophils. 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 Okay. A small correction. Acidophils. Basophils are also called cyanophils. Basophils are also called cyanophils. It's a small correction, please everyone. Okay. So eosinophils will be only 2 to 3%. That's it. Only 2 to 3%. 2 to 3% of total WBC. Only 2 to 3% of the total, okay, WBC. And These eosinophils or acidophils, they act against different infections. So resist infections, resist infections, resist infections, resist infections, the resist infections, and causes allergic reactions, causes allergic reactions, causes allergic reactions. Allergy, they involved in allergic reactions. They resist infections and involved in allergic reactions. Even basophils also, they releases one substance called histamine. They releases histamine. Basophils releases a substance that is called histamine, and these histamines will be leading towards the allergic reactions. The histamine which causes allergic reactions, like even not only histamine, it also secretes serotonin, one more substance, serotonin. Histamine and serotonin, they exhibit anti-inflammatory. Anti-inflammatory means against allergic reactions, against inflammatory reactions they will act. So anti-inflammatory, anti-inflammatory, anti-inflammatory reactions they involve in. Next, so coming to neutrophils, the neutrophils are also called heterophils. The neutrophils are also called heterophils. The neutrophils are also called heterophils. They constitute 60 to 65 percentage, 60 to 65 percentage of the blood. That means total WBC. Total WBC 60 to 65 percentage. Basophils, you may get a question, sir. What about the percentage of basophils? 0.5 to 1 percentage only. That's it. The basophils is very least percentage. 0.5 to 1 percentage. And highest number of cells in the WBC are of neutrophils only. Neutrophils only highest number of WBC. Neutrophils highest number of WBC. Neutrophils 60 to 65 percentage, that is 60 to 65 percentage neutrophils. Neutrophils highest percentage. Okay. Next, they are called policemen of the body or soldiers of the body. Yes, Megha. 1 second. Yeah, please.
Sir, what's the function of histamine and serotonin? Can you repeat, sir?
They act against, suppose whenever there is allergic reaction is going to develop in the body due to some allergens, due to some pollen grains or any infective agents, allergy develop. This basophils releases histamine and serotonin, and they act against that anti-inflammatory reactions. They give some anti-inflammatory reactions. Got it?
Thank you, sir.
They act against allergic reactions. They act against the allergic reactions. Okay.
Thank you, sir.
Yeah. Next, coming to neutrophils. The neutrophils will be the maximum number, almost 60 to 65 percentage. 60 to 65 percentage. 60 to 65 percentage. Soldiers of the body they are considered as, like microscopic policemen of the body or soldiers of the body. Soldiers of the body. Soldiers. Maximum percentage, and moreover, their function is to kill the different pathogens. Different pathogens they kill. Any doubts there? Any doubts? Yeah, please.
Why they are called as soldiers?
So because of their function is to perform phagocytosis. Phagocytosis means killing of pathogens. Killing of pathogens. That's why they are called soldiers.
Okay.
They are always in
Thank you,
search of the pathogens. They are always in search of the pathogen in the body and killing the pathogens. The killing of pathogens is nothing but a phagocytosis. What is the process called? Phagocytosis. Pronounce it.
Phagocytosis.
What is the phagocytosis means?
Killing of pathogens.
Pathogens. Killing of pathogens. And since they are involved in this killing of pathogens, phagocytosis process, they are considered as soldiers of the body, and moreover, their population is high, 60 to 65%. So they work like a soldiers in the body for the immunity,
sir.
for ensuring immunity to our body. They work like soldiers. So this is all about the granulocytes here. Once again, I will repeat all the points. I would like to repeat every point which are involved in the Neet syllabus, which are included in the Neet syllabus exclusively. Please concentrate again. Please concentrate one more time. Eosinophils, they are also called eosinophils. They are also called eosinophils. Basophils, they are also called cyanophils. Basophils, they are also called cyanophils. Neutrophils, they are also called heterophils. Neutrophils, they are also called heterophils. Heterophils. Neutrophils are also called heterophils. So eosinophils function. So they resist infections. They resist infections. They resist infections. They resist infections, and they causes allergic reactions. Causes allergic reactions. Allergic reactions. Causes allergic reactions. And coming to basophils, basophils will be, yes, not appearing. Straight away.
Sir, allergic reactions means what, sir?
Allergic reaction in the sense, suppose when any allergen, the agent which causes allergy, will settles on the body, it causes a lot of inflammatory reactions like itching sensation and redness, bleeding, this kind of things. That is called allergic reaction. And this eosinophils function is to develop that allergic reactions, right? So they are involved in allergic reactions. Eosinophils and basophils both, they act against the allergic reactions.
They act against those reactions.
Yeah, they act against the allergen. So the reaction is nothing but allergic reaction. Got it?
Okay.
When allergen enters the body, these eosinophils and basophils act against that allergen, and that reaction is called allergic reaction. Got it?
Yes, sir.
Whatever the symptoms we show is the symptoms of allergy.
Yes, sir.
The
Sir,
symptoms
why
of allergy is different. Allergic reaction is different. Got it?
Sir, if they act against those allergens, why do we get such reactions on the body, sir, like redness?
Because the immune reaction is like that. These agents will act against the allergens. Since they are acting against the allergens, we develop some activities, some process will happen, and it leads to the development of those kind of allergic reaction symptoms.
Okay, sir. Understood. Thank you, sir.
Next. Basophils are also called cyanophils. They are also same thing, but they secrete a substance called histamine and serotonin. Secretes histamine and serotonin, and this both also involves in allergic reactions or inflammatory reactions. Allergic or inflammatory reactions they involve. Allergic reaction they also involve histamine and serotonin. Histamine and serotonin. Next, coming to neutrophils, 60 to 65% of the white blood cells. 60 to 65% of WBC, not total blood, right? Total blood plasma only 55%. You cannot take like that. Neutrophils 60 to 65% of the total WBC. Only WBC 60 to 65% is neutrophils. and they are acting as soldiers of the body. They are nothing but soldiers of the body, not acting as. They are soldiers of the body. Soldiers of the body involves in phagocytosis process. They involves in phagocytosis of the body. Phagocytosis, killing of pathogens. So this is all about the three different granulocytes. Now coming to agranulocytes. Agranulocytes are again two types. Agranulocytes are of two types. Agranulocytes, two types. Lymphocytes and monocytes. Lymphocytes and monocytes. Lymphocytes and monocytes. Lymphocytes and monocytes. Lymphocytes 20 to 25% of WBC. Okay. After neutrophils, lymphocytes only second populated cells in WBC, among WBC, and they are very smaller in size. Very smaller in size. Smallest of all WBC. Smallest of WBC. Small size, very smaller in size. Lymphocytes. Okay, they identify the entry of pathogens. They identify the entry of pathogens and releases antibodies against them. Secretes antibodies. Secretes antibodies against pathogens. Against pathogens. Secretes antibodies against pathogens. So their function is they act like a watchman. When any thief enters the compound, he releases dog. The dogs are nothing but antibodies here. The dogs are nothing but antibodies. Thief is an antigen, right? And at the end, immune response is going to be exhibited. Okay. Next function, monocytes. Monocytes are largest of all the WBC. Size in terms of size, largest, and percentage is third, 6 to 8% only. 6 to 8% of the WBC. 6 to 8% of the WBC. This is only 0.5 to 1%. Basophils. Eosinophils will be less, 2 to 3% only. 2 to 3%. Okay, this is 60 to 65. Basophils up to 1%, eosinophils up to 3%, lymphocytes up to 25%, monocytes up to 8%. And they are largest size, larger in size. Larger in size. And they are largest of all the WBC. All WBC, they are largest. And their function is also engulfing the dead pathogens. Remaining neutrophils and lymphocytes, they kill the pathogens, right? With the help of directly or with the help of antibodies or any cells, mediated cells, they kill the pathogens. They are going to engulf the pathogens. Engulfing the pathogens. Engulf pathogens. Dead pathogens. Engulf dead pathogens. Engulf dead pathogens. So this is all about the WBC classification. This is all about the WBC classification. Please note down clearly. Okay, regarding this, if anybody have a doubt, please raise your hand. Regarding this, anybody, if have any doubts, please note down very clearly. With the help of a flow charts, I'm explaining all the concepts. Yes, Megha, any doubt? Now please tell me.
So you said that granulocytes, they possess some specialized granules. So what are the granules?
See how they look like. Suppose it is eosinophils. The cell looks like this, and the granules will be present like this. The granules will be distributed randomly. Okay, they respond to acidic stains. They respond to acidic stains. When we apply acidic stain, they respond. So they are acidophils. Next, basophils. The granules will respond to basic stain. Like that. Understood?
Okay, sir.
So I think the types of WBC is completed. And coming to platelets, what is the time now? So today, time has completed almost up. Tomorrow we'll continue with the topic platelets, blood platelets, and blood groups. Tomorrow we are going to study. If you have any doubts, please raise your hand. Otherwise, I'll end up the session. No doubts? Yeah. Shreya.
Mate, I'll copy, sir, if you move us. Yes, sir. Thank you, sir.
Okay, dear. Today I'm ending up the session. Thank you very much. Have a nice day. Please attend regularly.